Good afternoon, everyone. My name is Wirarama Wedashwara. Today, I will present our research with title Solar Powered Smart Anti-COVID Door Lock using camera and infrared temperature sensor. This is a collaboration between our researcher from Mataram University and our partner, Mr. Iwayan Agus Arimbawa from Seoul National University. The background of the research is a temperature measurement using an infrared thermometer is one of first step in detecting the potential for someone to be infected with COVID-19 virus, which close to our daily life. Okay, this measurement still has the potential to endanger the staff who will measure the temperature because the distance to the person being measured is quite close and must pass through the face. Okay. And our solution is a smart door locking system without physical human interface by using the Internet of Things or IoT and computer vision or CV technology. So we use feature recognition, which is here cascade classifier is used to ensure that the measurement of temperature in the eyes of forehead, so it makes sure not on wrong position. Okay. Detection of nose and mouth use as indication of usage of mask. Okay, and we also feature the solar power to the system for because most of the temperature check done in the front door of the building. So if we could use solar power, it will be good for cheaper term of operational costs. So developing a lightweight solar powered computing system is the target of its innovation in this research. Okay. So this is a relative related research, which mostly about IoT implementation on COVID-19 and medical field. Okay. So differential with our research is the process research is more of application of algorithm for automation of handling before entering the building, not after building. The proposed research does not use medical equipment, so we are not related to any medical thing in this. Focus on replacing our role of front office staff who are at risk for COVID-19. So the research used low power solar panel computing and was different focus, namely proposed research is more on face recognition and temperature detection to control the door lock. So this is the flow chart of our system. So first we need three parts, which is the IoT system, camera, and computer vision application, which all integrates in the Raspberry Pi. So first we detect nose and mouth detections. If is not detect, if it's detect, so is not detect, so we move to eye detection. If IR detect, so we measure the temperature right on the eyes. So if the normal, so we can unlock the door. So if the nose and mouth are detected or temperature is not normal, so it will be invalid and door are still locked. So we use night vision camera to make sure our face detection is not affected by the daily light or night. So we don't need pre-processing of image, so we can make a lightweight computer vision algorithm. Okay, this is a general view of the system. So all integrated in solar-powered smart anti-COVID door lock with computer vision and temperature authenticator, which relay module connect with solenoid door lock to lock or unlock the door based on temperature detections and camera. So power supplied by solar panel, TP charging module, and 10650 battery. So and also we have a OLED module to display the results to the user. Okay, so we use I2C port to this system. Okay, so this will be the evaluations of our system, black box testing, and solar power availability, and evaluation of my detection with night vision and camera and regular camera, and calibration of temperature with ambient temperature and regular contact thermometer. Okay, so this is the circuit of the system which we use in the new Raspbian OS on Raspberry Pi. We could use up to 3 I2C port. So in this case, we use 2 I2C port, which is parallel between GY 906 and OLED module, which together connect in different I2C module. So it can used by Raspberry Pi without any clocking system. So very simple construction in there. So and rail module will control the solenoid door lock, and we use low powered solenoid door lock, which can be used by 5 volt. Although it's a 6 volt, is still working, but maybe for optimal implementation, we need a more higher voltage for this. Okay, so this is the actual view of the system. So it's when all parts are connect. So this is a relay module connect in there. So it's designed as a Raspberry Pi head with double side PCB. So it's really simple to be used on Raspberry Pi. Just put it on the upper sides of Raspberry Pi, and we are ready to go. Okay. So this is the result of black box testing. So validation was carried out as 40 samples, which were divided into 4 conditions with variation of mass and temperature. So we use so in this experiment, we not use a person that really have a high temperature, so we lower the temperature to 69.8 to easily get the samples. Okay, so we do some sport to get this relatively higher temperature. Okay, so so we have 2 part of computer vision accuracy with normal camera and night vision camera. So we divide the 3 part of daytime, so it's morning, day, and night time. So the result showed that more were detected as unmasked. So it's not complicated as confusion matrix, but in this result, more of result are detected as unmasked. So maybe using mask, but still detected as masked. And the error rates is high in the morning and relatively lower in the night, because in the night vision camera is work and accuracy and maybe gray cycle will more clear. So it's result that maybe face detection are more easily using a hard cascade on the gray cycle result in night vision camera. So average accuracy is 0.867. Okay, so this is normal camera, so almost lower in many parts. So sometime in the morning have a hike like from sunrise. Okay, so it's a lower on the morning and night, and the average accuracy is also lower. So difference is 0.2, it's which like a 20%, and it shows a better using a night vision camera. Okay, so this is a calibration of GY 9.6. So in this result, we compare to ambient temperature and humidity sensor, DHT 11, GY or GY 906, and contact thermometer. So this show so the results that we expect is different with DHT 11 and similar with contact thermometer, not infrared thermometer, but contact thermometer. Okay, so it must be more accurate than GY. Okay, so it's have a 5.022 differential and 0.161 differential. So it's good point. So it's compared to like intensity, but in this data, we can measure the linear relationship between the light intensity and ambient temperature. So maybe in the next research, we should take a more data to get the relationship between them. Okay, so this is the availability of solar cell in there. So these results measure the temperature between power that come from the solar cell and battery. Solar cell indicate that power that generates by sun energy, and battery is which used by the Raspberry Pi and or IoT head. Okay, so this result in 24 hours, it's many things happen, but depend on the temperature. So in our previous research, temperature and electricity is effect to the power that generates by solar cell, and this data indicate that it's capable to run at the 24-hour. Okay, so conclusion, research is proposed a smart door locking system without physical human interface using IoT and CV technology. The research evaluation result in accuracy of 0.867 using a night vision camera and 0.687 using an ordinary camera for various light conditions. The evaluation of temperature measurement has calibration difference of 0.161 with regular contact thermometer and air temperature. The door locking system has valid result of all mass condition and temperature. Evaluation of system performance using solar power shows that system can run 24 hours with 6 watt peak mini solar panel and 1.2 ampere hour battery under condition of use of 40 visitor in one day without a visitor at night. Okay. So that's all our presentations. Thank you very much. Arigatou gozaimashita.